All right, so before we start this learning objective, you made it to the final learning objective of Algebra 2. All right, after this, you're just working on kind of mastering all the content you've learned throughout the year. All right, and our final learning objective is just taking what we did in the previous two learning objectives and just doing it with some type of context. Again, whenever you add context in math, it just means you kind of have a word problem situation. All right, so that's what this slide says. All right, we're just doing real world scenarios where sinusoidal graphs can model that real world scenario. All right, so one of the really common ones for this is Ferris wheels. All right, so in this case, you have a Ferris wheel that's on a platform 5 feet off the ground, has a radius of 20 feet. It takes 5 minutes to do a full revolution. All right, so we're going to create a sinusoidal equation that models our height off the ground x minutes after the ride. So if you think about our equations to create a sinusoidal equation, when you think about the midline, when you think about the amplitude, and when you think about the period. So real quick, I'm going to pause and draw a picture so we can kind of figure out these things based on the problem. All right, so here's the situation. You have not a great picture, but you have this little platform that's 5 feet off the ground, and you have this Ferris wheel with a radius of 20 feet. So to find the midline, you take the average of the highest and the lowest values that you're going to experience in whatever your situation is. So in our situation, the lowest you're going to be while you're riding the Ferris wheel is 5 feet off the ground, because right when you get on at the bottom of the Ferris wheel, you're on that platform, you're 5 feet off the ground. All right, the highest you're going to be is straight at the top, is up there. And how tall is that? Well, to get from the bottom of the Ferris wheel to the top, you do the radius twice. The radius is going to get you to the middle, and another radius is going to get you to the top. So the highest value is 45. And I want to average those two. So to average things, you add them together and divide by 2. And I get 25. So the midline of whatever sinusoidal function I come up is the average of the highest and lowest value, in this case, 25. The amplitude is the distance from the midline to the high. In this case, you would take the high value, 45, subtract the midline, and you get 20. So my amplitude is going to be 20. And then my period is how often it repeats. Well, it actually tells me it just repeats every 5 minutes. So my period is 5. But when I go to make an equation, I don't just put in the 5. I remember that there's a formula that the b value that goes in my equation is 2 pi over p. In this case, 2 pi over 5. All right, so just remembering all the stuff that you had to do in the previous two learning objectives, and now just kind of deciphering some of that from a word problem. All right, but now my equation is amplitude goes first. All right, we'll have to talk about what's going to go there. In parentheses is going to be my b value. X plus the midline is 25. All right, so all that's similar. The only really new thing you have to do in this problem is figure out, am I going to put sine or cosine in here? Because it actually matters if I put sine or cosine, because they're going to be slightly different. All right, so if I think about my cosine graph, cosine starts at the highest value and continues from there. My sine graph starts at the middle value and goes up and back down. Right? So what's happening in this situation? In this situation, I'm starting, when I get on the Ferris wheel, I start at the lowest value. And so how do I start at the lowest value? Well, cosine starts at the highest value, sine starts at the middle value. So neither of these start at the lowest value, but what I could do is I could flip cosine and make it start at the lower value instead. And the way I do that is make it negative cosine. So that's the only new thing that you have to kind of do in this learning objective that you haven't had to do before. I find the midline you've done before, the average of the highest and lowest. Amplitudes, the distance from the midline to the top. Periods, how often your graph repeats, all that stuff you've done before. And the only new thing is, am I going to do sine or cosine? So the basic idea is if I want to start in the middle of something, I'm going to do sine. If I want to start at the top, I want to do cosine. If I want to start at the bottom, I do negative cosine. So this over here is kind of the one really new thing in this learning objective you haven't done before. And so here's another one. All right. Halley's Comet. You can read. So you can just pause the video and read through this. Again, the main thing is finding those three main parts. So the midline, the amplitude, and the period. All right, so the midline is going to be the average of the highest and lowest. So the closest it gets is 60 million kilometers. So the lowest is 60. The highest is 5,500. And we find the average of those two values. 60 plus 5,500 divided by 2 is 2780. So 2780 is our midline. And again, our units are millions of miles. So you can just use the numbers rather than writing out all the extra zeros. The amplitude is the distance from the top value to that midline. So I just subtract those two things. So 5,500 minus 2780 means it's 2720 is the amplitude. And my period is how often it repeats. It happens every 75 years. So my period is 75 years. But my V value is 2 pi divided by that 75. All right, and this one just says create a sine equation that models the distance of the comet from Earth each year. All right, so that doesn't really tell you where it is right now or if you're starting at lowest. For this one, you can really do anything. So it's going to be 2720 sine or cosine of 2 pi over 75 x plus 2780. All right, so if it doesn't tell you like starting at a certain point or whatever, then you can just pick either sine or cosine. All right, so that gives us up into here. All right, but if I want to adjust my equation, if I knew Halley's Comet was visible in 1986, so Halley's Comet was at its closest in 1986, so I want to be at the smallest distance. So that's a negative cosine graph to start at the smallest. Right. So this would be the equation if I was currently in 1986 and I wanted to know the distance of Halley's Comet per year. But it's not 1986. That happened a certain number of years ago. So 2023 minus 1986 was 37 years ago. All right, so I need to this to happen 37 years ago. So to do that, I need a phase shift of sliding everything over 37 years. So I'm going to do plus 37 in there. All right, that part's not super important, but this is how you do it to make it even more accurate. So now if I plugged in a specific year like this year, all right, it would get it correct. And here's one more example. These ones are very common, is temperature goes up and down with the seasons. All right, so how could I find a function that models the temperature in Middleburg after the hottest day of the year? So first thing, midline, take the lowest, add the highest, and divide by 2. Let's see what that's going to be. 44 plus 89 divided by 2 is 66.5. So that's the midline temperature. The amplitude is going to be 89 minus that midline. $22.5. And the period is based on days. So how many days does it take the temperature cycle to repeat? It takes a full year, which is 365 days. So my B value is 2 pi over 365. All right, so amplitude goes first. I want to start on the hottest day of the year. If I want to start at the peak, I'm going to start with my cosine graph. B goes in the parentheses with x. And the midline goes last. All right, so that is, if I put in the X number of days since the hottest day of the year, that would give me the temperature I could expect in Middleburg at that time. All right, so here's one for you to try on your own. Are you jumping on a trampoline? You go up and down. All right, figure out a sinusoidal function that models your height above the trampoline. At any time, so the sine cosine part doesn't really matter too much for this one because it's not telling you where you're starting. It's just know at some random time. All right, so you can get something like this, 3 sine of pi x plus 1. Again, since it's not telling you you're starting at the lowest point or the highest point or anything like that, you can pick sine or cosine. But the amplitude ends up being 3. The period's 2 because you're repeating every 2 seconds. So 2 pi over 2 gives you pi is your B value. in your midline, the average of 4 and -2 is 1. So your final skill check of the year, you're going to do 2 problems taken from the practice problems. So look through the practice problems, make sure you can know all that. All right, and then repeat that on the skill check. All right, and then after you're done with this final skill check, your goal is to just kind of keep working on the stuff you've already learned in this year and master as much as possible for the end of the year.